Basic differentiation in calculus find the instantaneous rate of change derivative of a function, essentially how one variable changes as another change using a certain rule. Derivative represents the slope of the tangent line to a function at any point, showing its rate of change.
Basic differentiation rules. The derivative of c is equals to 0. C is equals to a constant. An example of this is the derivative of 3 is equals to 0. That's rule 1. And rule 2 is the derivative of x is equals to 1. And rule 3 is the derivative of n in the power of x is equals to x n in the power of x minus 1. An example of this is the derivative of 2n in the power of 3, which is equals to 3 times 2n in the power of 3 minus 1, which is equals to 6n in the power of 2. That's why in rule 2, the derivative of x is equals to 1 times x the power of 1 minus 1, which is equals to x in the power of 0, which is equals to 1.
Hello everyone, I am Jilly and I will discuss Rule 4, 5, and 6. Rule 4, Constant Multiple Rule. The derivative of c times x with respect to x is equal to c. This rule tells us that when x is multiplied by a constant, the derivative is just the constant because the derivative of x is 1. So the example from the slide, the derivative of 2x is simply 2. Rule 5, Power Rule. The derivative of c times x raised to the power n equals c times n times x raised to n minus 1. In this rule, we multiply the coefficient by the exponent, then subtract 1 from the exponent. Example from the slide. 7 times 5 is 35, and 5 minus 1 is 4. So the answer is 35 x raised to 4. Rule 6, Sum and Difference Rule. The derivative of f of x plus or minus g of x equals the derivative of f of g of f of x plus or minus the derivative of g of x. This means we differentiate each term separately. The example from the slide, we differentiate each term. 3x squared becomes 6x. 2x becomes 2. So the final answer will be 6x plus 2. So to summarize, Rule 4, keep the constant. Rule 5, multiply, then subtract 1. And Rule 6, differentiate each term separately.
So we do the same for the derivative of g of x. So then of course we do addition or subtraction to both f of x and g of x. So we have f of x plus g of x, and this would be the answer, and f of x minus g of x, and this would be the answer here as well. So rules 7 and 8 are trickier. The derivative of f of x times g of x is equal to the derivative of f of x times g of x plus f of x times the derivative of g of x. For rule 8, this is the derivative of f of x all over g of x, or f of x divided by g of x. So this is equal to g of x times the derivative of f of x minus f of x times the derivative of g of x. And this is all divided by g of x squared. So here we have an example. We have f of x is equal to x squared minus 4x plus 5, and g of x is equal to negative x plus 2. So here we're going to find the derivative of f of x times g of x. For x squared, that will become 2x. For minus 4x, we will just be left with minus 4. So here we have just negative 1, and plus 2 would just become 0, so there's just that. We have the derivative of f of x, which is 2x minus 4 times g of x. And g of x is negative 1. Is negative x plus 2. F of x, which is x squared minus 4x plus 5 times the derivative of g of x, which is negative 1. So our final answer, when we add all these together, we would have negative 3x squared plus 12x minus 13. So now let's try looking for the derivative of f of x divided by g of x. So first we get g of x, which is negative x plus 2, and we get the derivative of f of x, which is 2x minus 4. Then we subtract that by f of x, so we have x squared minus 4x plus 5, and then that's times the derivative of g of x, which is negative 1. Now this is all over g of x squared, so g of x, that's negative x plus 2 squared. Again, we have the negative x plus 2 squared under there. Negative 2x squared plus x squared, that is negative x squared. And then 8x minus 4x, that would be plus 4x. Negative 8 plus 5, that is negative 3. And that's all over negative x plus 2 squared. As much as we need, this can be our final answer now. So yeah.
So guys, thank you for listening and thank you for entertaining our video, and I hope you guys learn in this lesson.